Hi everyone, this video is all about inverse trigonometric functions. Why do you need to know about these? Because you always need to know about inverse functions. For example, e to the power of x, natural log of x. Squaring, square rooting. Okay? Sine, arcsine. You need to know about inverse functions to be able to do more things with them mathematically. So I'm going to talk you through how to find the inverse of sine x as a graph, how to draw the graph of the inverse of cosine x and the inverse of tan x as well. Okay? So for the inverse circular functions, so this is the graph of y equals sine x. Okay? Now, to find the inverse, we've got a problem because this is not a one-to-one function. Why is it actually one-to-one? Well, I'm going to take you back. Okay? I'm going to take you back to the functions unit, which you've probably already covered. Okay? If not, here's a very nice summary for you just to take a screenshot of that. So the important thing is about how functions actually work. So when you're drawing these graphically, so suppose this is your original function, f of x, your new function, the inverse function, written like this with a negative one, it's not a power, it means inverse function. You reflect that through the line y equals x. Okay? Now, a function only exists if it's one-to-one or many-to-one. So when you reflect a one-to-one function, you're going to get another one-to-one function through the line y equals x. However, if you sketch a many-to-one function like that, and then you reflect that through the line y equals x, okay, it looks like this, and that is no longer a one-to-one or many-to-one function. Okay, something like this is a mapping. It's a one-to-many mapping, and that's not a function, so that can't happen. So you cannot have a many-to-one function being reflected through the line y equals x to generate a function. And so for this reason, inverse functions only exist for one-to-one functions. That's very important. Inverse functions only exist for one-to-one functions. Okay? If you need to know more about that, then keep looking at functions and how they work. Okay? But for the moment, that's all you need to be aware of for this. So this is not a one-to-one function. So we've got to restrict the domain of this. We want to restrict it so it becomes one-to-one. So if you look from the origin, the obvious starting point, okay, from here to here, it is one-to-one. But as soon as it goes down again, it's no longer one-to-one, is it? Okay. So for this graph, we just want to restrict it between here and here. Okay, just to the maximum point. But then you can also go backwards through the negative values. You can also go from here to here. So what I've traced out in red, hopefully, if I just go over it a bit more in bold, that part of the sine graph is one-to-one. And so what we'll do is, for the domain of the sine x graph, we'll consider between negative pi over 2 and positive pi over 2 in radians. So negative pi over 2, pi over 2, and the range is between negative 1 and positive 1. Okay? How does that help us? Well, remember how inverse functions work. The domain and range, they swap around. Okay? Because the whole domain becomes the range and the whole range becomes the domain. If you're wondering why that is, just need a quick reminder. Okay? Remember how to find inverses. So the idea is that if you've got an original function here, write it as y equals 4x minus 3, and then you make x the subject to find the inverse. So you'll do plus 3 divided by 4, so you have x equals y plus 3 divided by 4. But to write the inverse, you then swap the x and the y around. Okay, you swap the x, so you swap the x and the y over, so you have inverse is x plus 3 over 4. It's the swapping over the x and the y, which means the whole range and domain gets swapped around. Because basically you're swapping all the x coordinates for the y coordinates. So, and that's why the reflection of the line y equals x works. Okay? So doing this also helps you to brush up on your inverse functions as well. It's a very important unit. Okay? So these are just going to swap around. So what I'm going to do is I'm going to show you what they are. So the domain of the inverse sine graph will be negative 1 less than equal to x, it's a domain, less than equal to 1. And the range of the inverse function will be negative pi over 2 less than equal to y, less than equal to pi over 2. It's these, okay? Sometimes it's written as arcsine, so just write that in there. So arcsine. I prefer this. You need to know both, okay? You need to know both of them. And then what you do is you just reflect this to the line y equals x, and your graph looks like this. Now what I'd recommend is, because you know the domain is between negative 1 and 1, label the x-axis between negative 1 and 1, make that a bit bigger for you, so negative 1 to positive 1, and the range is between negative pi over 2, so that's here, you see, negative pi over 2, to positive pi over 2, there. And then notice how the graph curves. Okay, passes through the origin, you reflect it through the line y equals x. Now, when you're reflecting through the line y equals x, if you look at this bit here, that's the stationary point. You've got a horizontal tangent going to 0. You reflect a horizontal tangent, you get a vertical tangent, which is why it looks like this, you see. Same with this. This is a horizontal tangent. If I just draw it a bit bigger, like that, there's my tangent. When you reflect that through the line y equals x, it becomes a vertical tangent, like this. What I'm getting at is why the curve bends this way around, like that, and why the curve bends this way around as well. Takes a bit of practice, takes a bit of getting used to. Now, something you might find interesting, I'll move away in case you want the screenshot of that. I did this myself. Basically, yeah, step by step how to find the inverse of a graph. So the sine graph, the original, be just the restricted domain. The dashed line represents the line y equals x. Reflect that to the line y equals x, you get this new blue line, and then remove the bits we don't want. This bit here is the graph that we need. Okay? Maybe, if you've not done this before, you have a go at the cosine graph and find the inverse cosine function. Pause the video and then just play it again just to see if you were correct. The first thing we do is we're going to find how we restrict the domain of this graph. So if we chose the same domain, it's not going to work because here, look, that bit there is not one-to-one. Okay, so you've got to find it such that it's one-to-one. So if you start here and go right, you don't want to go left because as soon as it goes back down itself, it's no longer one-to-one. So what you'll do is you'll stay here and keep on going until the graph goes back on itself. And it's going to be this point here. So between here and here, that is where the graph is one-to-one. So the domain you'll need is between 0 and pi. And the range between -1 and 1. So when you do the domain and range of the inverse function, sometimes written like this, arccos. By the way, it's always the arc, ARC, preceding the cosine for the inverse function, if you're writing it this way around. So what you do is you'll do the domain between -1 and 1. So the x-axis you'll label to -1 and 1. Here's the interesting thing, y is always positive. Okay, so it's between 0 and pi, you see. So here, 0 up to pi. And then you just sketch the graph. Okay? Easier said than done, right? What I'd recommend is here, look, see the y-intercept. When you reflect that through the line y equals x, that becomes the x-intercept. So the point 0, 1 becomes 1, 0 there, you see. And vice versa, the x-intercept, that's pi over 2. So pi over 2, 0, that becomes the y-intercept. So 0, pi over 2 there. I'm just giving you tips as to how to actually draw this in. And bear in mind what I said about the gradients. So the gradient of that minimum point there is 0, so that you've got a horizontal tangent. That becomes vertical. So that's going to be here. See? And the coordinates just get swapped around. So pi, -1, just becomes -1 pi. And similar to this one here, horizontal tangent, looks like this. Yeah. I'm just going to set the board, just so you can see the graphs. And I'll show you this screen as well. So again, it covers a nice summary of it. Okay, I won't talk you through this one now. It's for you to just look at in your own time if you wish, but hopefully you get the idea. It's just a nice summary of the steps to draw the inverse function of cosine. Next one, we'll do the tan graph. In some ways, my favourite because it's got all the asymptotes. That's a fantastic word, isn't it? Asymptote. Just don't linger over the first couple of letters. Obviously, okay. Depending on what school you're in, if you start talking about asymptotes, you might get a big laugh, okay, from a more raucous bunch, okay. So that's why you heard them say asymptote, just all in one word, asymptotes, don't linger, okay. First, can you imagine that if you're going to lesson? Right, first of all, people, I need to see your asymptotes. They're just all sorts of wrong, isn't it? All sorts of, so yeah, just don't even go there, okay, so yeah. Right. It gets even worse if you start, that's a beautiful looking asymptote. Can you imagine how you could just seriously mess up that line if you just lingered? Anyway, I digress. I'm sorry if I'm offending any of you good people. These are the sort of things I can put in my YouTube videos, but not really in class. Okay, so, yeah. But here, what we're going to do, let's get back to the maths. So, yeah, to restrict it so it's 1-to-1, we're going to do this bit here, okay? Now, we have to talk about asymptotes, of course. When you're reflecting the whole graph through the line y equals x, the asymptotes get reflected as well. So you reflect the asymptotes here and here. Okay, but we'll get into that in a minute. First of all, notice how the domain and range are restricted. So negative pi over 2 less than, because you can't have tan of negative pi over 2, it tends towards infinity, or negative infinity, shall I say. Less than x less than pi over 2. The range is the whole set of real numbers. Okay, so it extends indefinitely upwards and downwards, so negative to positive infinity for the y values. So they get swapped around. Okay, so for the inverse tan, so that's called arctan, which is why it's in there. So basically, that's why the graph is looking longer than it is height-wise. All right. So the whole of the domain to be the x-axis here, negative infinity to positive infinity. Now, remember said about the asymptotes. When you reflect a vertical asymptote, it becomes horizontal. So this one here, negative pi over 2, that becomes a horizontal asymptote at y is negative pi over 2. And this one here, that becomes a horizontal asymptote here. And when you've got the asymptotes in, and you know it crosses the line, so it crosses the origin, it's quite an easy one to draw. Okay, because it's got to bend towards the asymptote, doesn't it? Okay, so the curve just looks like this. Now move away, and last, just a summary of those there point. Okay, right, I'm hoping you got something out of that. Thanks for tuning in, thanks for watching. Okay, I'll see you again soon. Bye bye.